going to try to go slower in these 4 sections just because this is really important building. If we don't understand today what radians are, then tomorrow when we start making a unit circle, it's going to be more complicated. So every single day, I'm going to try to go slower. If I get too fast, tell me. But it's also going to be super important, especially those of you that are on phones and have earbuds in and all that stuff right now. If you don't understand something, you need to ask that minute, that day. Okay? Don't wait. Don't wait to do the assignments until it's almost time for the test. You're going to be in trouble. Okay, so we're going to go back to angles, back in geometry, my faith. We know what an angle is, right?
Yeah.
Okay, so I'm going to draw an angle here. Okay, this side right here is the initial side. Initial side of your angle. That's where the angle starts. The side where it stops is the terminal side. And that's going to be important because later we're going to hear a word called coterminal. So initial side is where the angle starts. The terminal side is where the angle ends.
How do you distinguish the two?
That's what I was looking to see when they talk about this. It is because in standard position, the initial side, and everything, I think everything we're going to look at is going to be in standard position. It always starts, if you were on a circle, where would, well, you haven't seen that yet, so I can't say that. On the x-axis. Standard position, the initial side is always going to be on the positive side of the x-axis. Standard position means the initial side, in other words, where the angle starts, is on the positive side of the x-axis. So in other words, it's always going to start right here, right there.
That's the initial side of my angle.
Unless they tell you otherwise, I don't think we're going to see anything that's not that situation. Okay. Do you remember, this is going to come up in every single section we do, except for the very last one, your quadrants. The names of the quadrants.
Some 1 through.
This is quadrant 1, written with a Roman numeral. This is quadrant 2. This is quadrant 3. This is quadrant 4. Okay. A quadrant angle is an angle where both sides, the initial side, which will always line a quadrant, an axis, and the terminal side also lies on an axis. Quadrant angle. Angles where both sides are on an axis. So for example, a 90-degree angle, like if I drew in a 90-degree angle right here, I would call that a quadrant angle because both of those sides are on the axis. Does that make sense?
Mm-hmm.
Like exactly on one of those axes. What's another angle that would be a quadrant angle? 180 degrees. Another one?
0.
0 degrees. Where? Somebody said it. 270. 270 would be down here at the bottom, and if I went all the way around, 360. So those are quadrant angles. Okay, so now then, the first thing that we have to do is to be able to, remember in the calculator I always told you to be in degree mode?
Mm-hmm.
Well, the other mode is called radians. So we have to understand how these two things are related before we can move on. Radians. Okay, I'm going to tell you, and this piece of information will make more sense when we actually do the unit circle starting tomorrow. But if you start at 0 degrees and you go all the way around the circle, that is 2 pi radians. All the way around the circle is 2 pi radians. Well, I also know how many degrees are in a circle, the full circle. 360. So if I look at this equation and I divide both sides by 2, the relationship that I get is that pi radians is equal to 180 degrees. This is what we need to know. 180 degrees is the same thing as pi, just a different unit of measure. So the first thing that we're going to do is convert back and forth. And I'm skipping around a little bit. I don't like the order that this book puts this in, so I'm going to skip around just a little bit. So this is from example 4, if you're looking in your book. We're going to convert from degrees to radians. 60 degrees. Well, what if I'm working in radians, and when we get to the unit circle, we are going to talk a lot more about radians and use that a lot more. So how do I know what 60 degrees is in radians? Well, when we're doing conversions, like if I were converting inches to feet, it's the same thing that we're doing here, just different measures. So if I'm going to, here's the relationship. If I'm going to convert this to radians, I need the degrees to cancel out, right? So I'm going to put 180 degrees on the bottom because that way the degrees cancel out and it's going to leave my answer in radian form. So pi is equivalent to 180 degrees, pi radians. I put the degrees on the bottom so that those units cancel out. So on top, I've got 60 pi. On the bottom, I've got 180, but I'm pretty sure 60 over 80 will reduce to 1/3. So on top, I have pi, and on the bottom, I have 3. You don't need the 1 on top since there's something else up there.
So does that mean that's like a third of a radian?
1/3 of a radian. A 150 degrees. 150 degrees. So I know the relationship here. If I'm converting from degrees to radians, I know the relationship 1 pi radian is equal to 180 degrees. I want to convert to radians, so I want the degrees on the bottom so that that will cancel out. So pi is going to be on top. So if I cancel those degrees out, I'm going to have this in radians. 150 pi on top, 180 on the bottom. I'm pretty sure that will reduce to anyone? Anyone?
Would be 5, 6.
3 goes in 5 times. I've got a pi on top, and 3 goes in 6 times. 5 pi over 6. Negative 45 degrees. And in just a second, I'm going to show you a negative angle, so that will make more sense. But right now, we're just going to go with it. Negative 45 degrees. I want to convert this to radians. I don't know why I put an equal sign there. So again, degrees go on the bottom so that that will cancel out. The pi goes on top. So on top, I have negative 45 pi. On the bottom, I have 180. The degrees canceled out. So what's that reduced to? 45 over 180. Negative 1/4. So negative pi over 4. I don't need the 1 on top since there's something else up there. Not yet. It doesn't get much worse in this section. Okay, is that okay? Yes? Okay, let's go the other way before lunch real quick. Let's see example 5. We're gonna go the opposite direction. I'm gonna give you radians and we're gonna convert to degrees. So let's say, if I tell you that it's pi over 6 radians, pi over 6 radians, I wanna convert it to degrees. Okay, so this time, since I want to go to degrees, the pi is going to go on the bottom so that that will cancel out. Pi radians on the bottom, 180 degrees on top. So these pi's are going to cancel. So I end up with 180 over 6, which is 30 degrees.
Yes.
So it's not any harder that way either. Do what? Yes, this. Flip it so that whatever you need to cancel out cancels
Are you
out.
always gonna use that, the I and the 180?
Yes, always.
Okay.
Let's see. 3 pi over 2 radians. 3 pi over 2, I want to convert this to degrees. So if I want to go to degrees, I'm going to need 180 degrees on top, the pi on the bottom, so that this will cancel out. So what do I get here? 3 times 180 over 2. Well, 180 over 2 is 90, and 90 times 3 is 270. It's just a little bit of math.
And it's
Well, you know, you've seen grade here, you know we can't do a little bit of math.
I don't have PhD.
Okay. We'll be back after lunch.